All right, number 21 of the 92 final exam review starts with a linear equation. I know it's a linear equation not only because it tells me, but because I have a variable raised to the first power. What do I know about this equation? I just want to mention it's not a quadratic, right? It's a linear. What else do we know about it? That it's also in slope-intercept form. That's the slope. That is the Y-intercept. Slope-intercept form is y equals mx plus b. So this is the b, this is the m, okay? Just for letting you know. But for our purposes, it just says you want to plot the points. So if you can picture, this kind of goes like this, right? And it wants to say, okay, if x was -2, if x is -2, what would y be? So I like to write my, if I'm using fractions for my slope, I like to put my whole numbers and my integers into fractional form, so I know that I'm kind of multiplied across at the top. This is going to be a -14 divided, negative times a negative is a +14, divided by 2 is a 7, plus 3 is 10. Okay, so that's a 10. The ordered pair that would work as a solution to this linear equation would be -2, 10. -2, 10 would go there, okay? Because it's a linear equation, every dot that I put on this line it'd be a straight line, right? So if we graph it as we go, we'll notice if we make any mistakes with our multiplications here, our computations. All right, the next one says we're going to put in, I should do it in a different color. All right, so the next one says -7, 2, and we're going to put in a -1. So this is -1 times -7 is a +7/2 plus 3. Now remember how we need to make a whole number 3 in terms of 2. A whole number 3 in terms of 2. That would be a 6/2. Okay, so that's going to be a 13/2, which is the same as a 6.5. So since we're graphing it, let's go with a 6.5. Let's see, it says write your answer using decimals or reduced fractions, so it would take either one, but to graph it, I'm going to go with the decimal. So where is -1 and then up to 6.5 is about right there. Okay. And the next one says -7/2 times 0 plus 3. So that's going to be 3, right? Anything times 0 is 0. So 0, 3. This is also what? This is also our Y-intercept, or our B. Okay. Notice that this is your Y and this is your X axis. Let's see. Then we want to do, I just did pink. Do the weird blue. I can't see that. How about red? -7/2 times 1 plus 3. So that's -7/2 plus 3 is, how do we do that? We're not going to be able to use the 3. What was 3 as a that was 6/2. So that's going to be a -1/2 for that one. So when x is 1, I should be writing this over here, is a -1/2. So 1 -1/2. this was 0, 3. This was negative 1, 6, 5. Okay. Let's see. 1 and negative half. That's right there, right? Kind of, sort of. I forgot to write the... I think it's nice to put the ordered pairs right on the graph next to the line. So notice we are making a nice straight line. I got one more. I got a, let's go back to blue here. I've got a 2. Y equals negative 7 times 2 plus 3. So this is going to be negative 7 plus 3. That's going to equal negative 4. So the ordered pair would be 2, negative 4. 2, negative 4, right there. 2, negative 4. And if this, like I said, if this doesn't make a straight line, you've done something wrong, okay? All the solutions to a linear equation make a straight line. Notice the slope goes in the correct direction. This is a negative slope, so that goes always, negative slopes always go that way. Okay, the rise over run is from, rise over run is from point to point, okay? So, for example, this one right here, what was the slope? The slope was negative, I can hardly read it anymore, I got so much stuff going on. Negative 7 over 2, let's see. 7 over 2, let me write that there. That is the same as what? 2 into that goes, it's like negative 3.5. So this is going down, negative 3.5, and it goes over 1, right? So the rise is, you can actually rise up on one side and go back, or you can go down 3.5 and over 1. So that's the slope from point to point. Okay, just a little reminders there on that one. All right, 22, graph the inequality, then graph the solution and give interval notation. All right, this is an and, because it's got a double symbol going on. Step 1 is to clear everything away from the x in the middle. So we start with a constant term, and whatever we do to 1, we do to everything. And now we need to divide by negative. When we divide by negative, it flips all the symbols. Flip when dividing by negative. Okay. So this is going to be a negative 2, and now a greater than or equal to x, and then a whoops, I said greater than, and I wrote a less than. Greater than or equal to, greater than a negative 4. Okay. If I have to graph these, I like to take them apart. That is, x is greater than negative 4, and x is, notice how this points to the x. We want it to point to the x. X is less than or equal to 2. So let's go up here. You can, since I'm going to eventually need my interval notation, I like to use the interval notation on the graph. So it's a soft bracket on a negative 4 facing up. And it's going this way. And then it is a hard bracket because it's less than or equal to on the negative 2. So that's that way. If you're using circles, this would be an open circle and that'd be a closed circle. I like to use interval notation because you go right up here and go, this is a negative 4, comma, negative 2, hard bracket. Okay. That's the answer to that one. Let's do another one. This one is another and written a different way, but we're just still going to solve for x. So move the 5 over. Can you see that? Let me try a different color here. Let's see if the green stands out. Not a lot of difference. So I move the 5 over this way, so that means the 9x needs to come over this way. That's the way I like to do it. It's kind of nice and neat, keeps everything straight. and 7x is less than 14. Get my x alone. I do not change the sign because I'm not flipping anything. So that's going to be x is less than 2 for that side. And then this one, let's see, move the 7. So I'm moving the 9. So this is negative. When I'm working on inequalities, I always move things to the left to keep things. I always move my variable term to the left because I like to keep my variable, my x or whatever letter it is, on the left side so I don't make a mistake with the symbols, these things here, when it's an inequality. But it's not wrong if you don't do that. It's just a good habit. All right, now I do have to divide by a negative. It's not a big deal. I just need to flip the sign. And negative 5 over negative 5 is positive 1. So this is and x is greater than or equal to 1. So it doesn't say anything about interval notation. If you need to put this together for some reason, 1 is smaller than 2, right? So the 1's on this side. It's open when it goes to the x. And 2's on that side. That's an and, right? So let's see. X, but to graph it, I still look at this. X is greater than or equal to 1. So dot-wise, it's a solid dot, greater than or equal to. So it's going that way. So it's also this, right? And then the 2 is an open or a soft. Okay, so this is going to be 1, 2, like that. All right. Back to factoring. Let's do pink. This is going to be x plus 2 pluses in the problem, make 2 pluses in the answer. Factors of 12 that add to 8 is a 6 and a 2, not a 3 and a 4. Has to be specific, okay? X is a perfect square minus a perfect square, so root, and then opposite signs to make sure the middle term goes away. So that's going to reduce to x plus 2, x minus 2. This review is not going to go in order because your final is not going to go in order. So it's a better review to mix it up a little bit, to do different things in between other things. Let's do one more. Solve each of the given inequalities. Use interval notation for your answer. All right, so I've got an or and I got an or and an n, but I'm still just solving for x here. So. What's your signage here? I did not divide by a negative, so I'm not flipping it. I just happen to have a negative on that side. Now I'm dividing by a negative, so I will flip the symbol this time. Positive 5. All right, so this one, even though it didn't tell me to graph, I like to graph these just to make sure I'm getting everything going the right way. So there's the negative 6, there's the 5. Now the negative 6, it said it was less than or equal to, so it's going that way. The 5 is a soft bracket, greater than, and it's an or, so needed all the little parts of this one. That's the union you put between them. And 5, and it's positive infinity there. So that's your answer for that one. Okay. This one's an and. You're going to solve the problem the same exact way, and you'll get the same exact thing. Let me put this in a different color. right? It's all solved the same way. In fact, the graph is going to look exactly the same way, obviously. But notice the union covered this gap here. But since this is an and they go in opposite directions, there's no overlap here. All right, so they have how can one dot be in both graphs? It can't be. Up in the or, you could have something here or something here, and that would work. But you can't have something here and something here. That's just not physically possible. So this answer doesn't exist, or it's a no solution, or there's an empty set, or however they want you to say it, okay? That's the answer to that one. All right, next video.